We continue the discussion of dimensional homogeneity and try to carry out an example, an exercise, and we see that each term of an equation have the same dimension. So there are two things that we were mentioning. One is each term should have the same dimension of an equation. The second is that both sides of the equation should have the same dimensions. And we can, later on, we will see that how we can make things non-dimensionalized. That is, each term becomes dimensionless, and how to do that. Very simple technique, but we come to that later. First, we try to work out this example, and we see the Bernoulli's equation is P plus half rho V square plus rho GZ is equal to constant. So it can be written in different forms. Sometimes we divide throughout by rho, sometimes not, but they are all equivalent forms of Bernoulli's equation that we have come to know. Now that it is given in the present form, we have to see in this question that each term has the same dimension, and when we say the same dimension, I mean the primary dimensions that we just defined. So that's the question. Verify that each additive term in the Bernoulli equation have the same dimension, and what are the dimensions of constant C. So the right hand side should have the same dimension as each term on the left hand side, because that's rule of the game. If it is not so, we have a problem. So the Bernoulli's equation as written, P plus half rho V square plus rho GZ, and its dimensions can be computed, can be calculated, which are not very difficult. Now let us see the first term, which is pressure. Pressure is equal to force per unit area, and force is mass into length per time square, as we have seen, divided by, since pressure is force per unit area, and what is area? Area is length square. Either it is length into breadth or length into length, so it will be length square as far as the dimensions are concerned. When we simplify all of them, the dimensions of the term reduce to m by t square times L. The second term, half rho into V square. Half is a constant, so it will have no dimension. Rho is density, which is mass per unit volume, times V square, and velocity is distance over time square. So they will have the relevant dimensions. For density, we have mass over volume, and for velocity, we have length over time square. When we simplify them and cancel out neutralize the terms that do with each other, and the simple, we are left with m over t square into L. And the last term in the Bernoulli's equation on the left hand side is rho GZ is equal to mass over volume, then times G is length over time square, the same as that of acceleration, because G is acceleration due to gravity, times the height, the length. Simplifying them, it also reduces to m over t square L. So all these terms have the same dimension as we have seen. And for the right hand side, from the law of dimensional homogeneity, that is, the equation on the left hand side and the right hand side should have the same equations. Therefore, C will have the dimensions mass over t square times L. So they are the same. And if the dimensions of any term were different from the others, then that should have alarmed us that there is a problem and we need to address that. All terms should have the same dimensions.